In this video here, we're going to go over sprinting mechanics and how we can improve mechanics in order to improve speed. In order for an athlete to improve their speed, the first thing we need to look at is trying to improve their mechanics and make them as optimal as possible and as efficient as possible when we run. The big thing to note is there's two different phases to sprinting. There's an acceleration phase and there's a top-end speed phase. These two phases have slightly different mechanics in which we need to understand in order to optimize running. This video here, you'll see me in acceleration phase initially, a little bit more of an angle. I'm trying to drive myself and get to full speed as fast as I can. And then as I get up to speed, I'm going into top-end speed phase. We'll start off by looking at acceleration phase. Acceleration phase, we're going from 0 to full speed as fast as we possibly can. Really trying to drive ourselves forward at an angle, striking underneath the hip, keeping that foot nice and rigid so I can push myself forward and get up to full speed. Then I start transferring into what's called top-end speed phase. Top-end speed phase, I'm in a little bit more upright posture. I'm still trying to strike underneath the hip, really trying to get myself forward as much as I possibly can and maintaining speed, elbows still at 45-degree angles, and heels staying off the ground. We're going to break down acceleration mechanics in detail first. Acceleration mechanics, you'll notice I'm going to drive out my first step here at a 45-degree angle as optimal as possible. Really pulling that back knee into recovery position nice and big. When my knee comes up, my toe is going to follow. When I strike the ground, I'm keeping my ankle nice and locked, foot nice and rigid, so I have a strong surface to push off of in order to push myself forward and trying to maintain those angles as long as I possibly can so I can push as much as I possibly can forward. Here, you'll see me at a 45-degree angle. That's the optimal angle for us to be able to accelerate as fast as we can. We don't want to be too low because then we'll strike out in front. We don't want to be too upright because we're not going to be able to get out in front or get forward as fast as we possibly can. When that knee comes up, that toe is going to follow. Those shins should be ideally even, so we're able to strike underneath of our hip when we go down in that first step. And we're trying to strike underneath of us so we can push ourselves forward as much as we can and trying to get up to speed. A good thing to note is when we're coming out of first step and we're accelerating, we don't want that back leg to recover towards our butt. You'll see space between my butt and my heel. We want that foot to stay low to the ground. We want to keep that heel away from our butt so we can get from point A to point B as fast as we possibly can. The faster we can get from point A to point B, the faster we're going to be able to get back on the floor, the bigger movement we can create, and the less we're going to be stepping out in front. If we step out in front when we accelerate, we're going to be putting the brakes on a little bit and really not getting forward. And we're going to try to maintain that mechanic throughout the acceleration phase. We don't want that heel coming towards our butt. We want that foot staying low to the ground, that knee coming up nice and big, and we're trying to get forward as much as we possibly can so we can really drive and accelerate as much as we possibly can. Now we'll look at top-end speed a little bit here. When I get up to speed, notice I'm in a little bit more upright position. The elbows are still 45 degrees. The knees are coming up big. The heels are slightly still staying off the ground, and I'm trying to maintain that speed and really get forward. When we look at the posture when we're up to speed, the shoulders, hips, and foot should be stacked on top of each other. I'm a little bit out in front on this strike here. That foot should be ideally directly underneath the hip as much as we possibly can. You notice the heel is off the ground, but we're definitely in a more upright position. When the foot hits the ground, we want that heel to be up slightly, and we want that foot to be underneath of us. If the foot is out in front, we see that very often. That means the athlete is reaching. If that heel is on the ground, we're kind of putting the brakes on a little bit. We want to be on the ball of the foot and really pushing ourselves forward. When the foot makes contact with the ground, the knees should relatively be even. If the knees are not even, that means the athlete's probably reaching out in front too much, or the back leg is not recovering into a good position. They're reaching back, or their posture is out of position. They're leaned over too much. Now that foot's going to start recovering more towards their butt, and we're trying to create a cyclitic pattern. This is when we're going into our cycle. You kind of see a circle here of the legs moving in that circle, so we're able to generate as much force underneath the hip and really keep getting ourselves forward as much as possible. Not reaching out in front, overreaching. We're trying to strike underneath the hip as much as we can so we can maintain that speed that we developed in the acceleration phase. When it comes to a couple more things, when it's acceleration and top-end speed and sprinting, we're trying to generate as much force as we possibly can. And in order to generate as much force as we possibly can, we have to do a big movement as fast as we can. We want nice, straight, strong lines of force where we're at the 45-degree angle when we accelerate. We want the knees up nice and big. We want to get down to the ground as fast as we can. We want our ankles to be locked, our foot to be rigid, so we have a strong base to push off of and allow us to optimize all of the force we're putting into the ground and use the mechanics as best as we possibly can. So when it comes to top end speed, when it comes to acceleration, when it comes to sprinting, optimizing these mechanics, making these mechanics as strong as possible, and utilizing these concepts is really what's going to make us faster. Once we get these mechanics down, we can start generating more force. We can start getting stronger. The stronger the athlete with the better mechanics, the faster we're going to be able to go. We want to be able to drive out as much as we can in acceleration phase, maintain that acceleration phase as long as possible, and drive into the ground. And then as we get out of the acceleration phase, we start coming more upright and we're trying to maintain that speed. When it comes to athletes in sports, a lot of times they're going to be using that acceleration phase, but they tend to use more top-end speed phase mechanics because it feels more comfortable. They're not at that angle, they're a little more upright when they run, and they're really not optimizing mechanics in order to sprint.